Assalamualaikum and hi everyone. My name is Nur Izati binti Cik Roslan with metric number S60275. Today, I'm gonna talk about my proposal for final year project, which the title is Green Synthesis of Magnesium Oxide Nanoparticles from Curcuma longa L and its band gap properties. There are four major contents in this proposal, which is introduction, literature review, methodology, and expected result. Introduction. Research background. Nanotechnology is most usually associated with particles smaller than 100 nanometers and nanomaterials made with nanoparticles. Nanotechnology has emerged as a promising technique for sustainable agriculture with various advantages for the agro-ecosystem, including soil remediation, climate change mitigation, and improved nutrient use efficiency. Nanotechnology is an excellent research that contributes to the top-down and bottom-up approaches by incorporating physical, chemical, and biological, such as plants, microbes, and biomaterials processes for the creation of multifunctional nanomaterials. Because to their single physiochemical features produced by their nano-size dimensions and huge surface to volume ratios, nanomaterials provide promising chances for enhanced and tailored assets to utilize in a variety of fields. Applications for nanomaterials are flat panel display, solar energy converters, optical amplifiers, electroluminescent devices, photodiodes, and also biodetectors. Green synthesis approach. Magnesium oxide is particularly beneficial in consumer-friendly technologies such as fluorescent lights and plasma display panels. MgO is a widely used wide bandgap semiconductor insulator that crystallizes in a cubic shape similar to rock salt or sodium chloride. MgO is also noteworthy because of its multifunctional application in water purification, catalysis, refractory, paint, luminous ceramics, and superconductor products. MgO nanoparticles are shown to catalyze efficiently in a range of organic processes due to their large specific surface area. Because of their unusual properties and numerous applications in material science, physics, and chemistry, magnesium oxide nanoparticles have gotten a lot of interest. Problem statement. MgO is a non-toxic primary metal oxide that has been used as a modifying agent, catalyst, and as a supplement in superconductors and refractory materials, as well as a restorative agent in the pharmaceutical industry. Significant features of MgO such as low electrical conductivity, high thermal stability, and catalytic performance could be produced experimentally after the particle size is reduced to nanoparticles. Salt gel flame spray pyrolysis, aqueous wet chemical, hydrothermal, laser vaporization, combustion aerosol synthesis, chemical gas phase deposition, and surfactant techniques are common ways for fabricating MgO nanoparticles. They are, however, expensive and can produce dangerous byproducts, or even the product itself can be quite poisonous. Significance of study. Magnesium oxide nanoparticles and their band gap properties have been the subject of extensive research. Green chemistry for chemical synthesis addresses our future challenges in working with chemical processes and products by inventing novel reactions that minimize desired products. while minimizing byproducts, designing new synthetic schemes, and apparatus that can simplify chemical production operation, and searching for environmentally and ecologically benign solvents. Nanotechnology and biomedical sciences present a wide range of biological study challenges and medical application at the molecular and cellular level. The use of biosynthesis to make nanoparticles has been advocated as a cost-effective and environmentally friendly alternative to chemical and physical methods of nanoparticles production. Research objectives. The objectives of this project are to synthesize magnesium oxide nanoparticles using plant extract of Curcuma longa L, to characterize the physical and chemical properties of magnesium oxide nanoparticles using X-ray diffraction XRD, Fourier transform infrared spectroscopy FTIR, UV spectroscopy, scanning electron microscopy SEM, and thermogravimetric analyzer TGA, and also to investigate the band gap properties of characterized magnesium oxide nanoparticles. Literature review. Magnesium oxide nanoparticles. Magnesium oxide nanoparticles have gained a lot of interest among metallic and PIS because of their non-toxicity and unique physical and chemical properties. To make NPs, a variety of chemical and physical methods have been explored. However, due to its more stable nature, non-toxic, eco-friendly and cost-effective qualities, green synthesis of magnesium oxide nanoparticles is preferably to other approaches. Biologically synthesized NPs have been thoroughly documented in recent years, and they now serve as the best alternative to previously available expensive and environmentally destructive physiochemical processes. Curcuma longa L, commonly known as turmeric, is a plant that originates in Asia and has since spread to other countries. 1,7-bis-4-hydroxy-3-methoxyphenyl 1,6-heptadiene 3,5-dione is the international standard name for curcumin. There are 5 characterizations: X-ray diffraction XRD, Fourier transform infrared FTIR, UV spectroscopy, scanning electron microscopy SEM, and also thermogravimetric analyzer TGA. Band gap properties. MgO is a highly insulating material with a high optical band gap of 7.6 electron volt in bulk, yet nanostructures of this material have a different optical band gap. MgO nanoparticles with a size of 7 nanometer have an optical band gap of 2.8 electron volt. The optical band gap of these materials' one-dimensional nanostructures is 3.2 electron volt. Magnesium oxide nanocubes have an optical band gap that is similar to that of MgO nanocubes. MgO is a shell-shaped semiconductor with a band gap of roughly 7.8 electron volt. In the rock-salt confinement is defined as observed changes in the material's optical and electrical properties. Methodology. Preparation of Curcuma longa L extract. The fresh leaves of Curcuma longa L are collected and doubly washed with distilled water, with 10 grams of fresh leaves and crushed into tiny pieces. Add 100 ml of distilled water, stir, and then heat at 80 to 95 degrees Celsius for 30 minutes. The resulting solution is filtered and polyethylene filter paper and further used to synthesize of magnesium nanoparticles, and also can be prepared in a grinding machine. The Curcuma longa L leaves are ground into a fine powder. In a 5 500 ml flask, 30 grams of the powder is mixed with 300 ml distilled water and heat for 20 minutes at 100 degrees Celsius. For maximum extraction, the mixture is incubated overnight at 37 degrees Celsius in a shaker. After that, the extract is filtered twice with Wetman filter paper grade 1 and keep at 4 degrees Celsius for further processing. Preparation of magnesium oxide nanoparticles. The synthesis of magnesium oxide nanoparticles was started by mixing 10 ml extracting with 10 ml 1 nanomolar magnesium chloride solution at 90 degrees Celsius and stirring at 900 rpm. After reaching 90 degrees Celsius, a dropwise addition of 2 molar NaOH solution was added to the combination and the mixture was aged for 3 hours to optimize the development of the magnesium hydroxide precipitate. The precipitate was removed from the mixture by centrifugation at room temperature for 20 minutes at 7,500 rpm and the precipitate was washed twice with ethanol 99%. To eliminate any remaining water and ethanol, the precipitate was dried in an oven. After drying, the precipitate was calcined for 5 hours at 600 degrees Celsius. Expected result. This is the expected result that we wish to get from SRD, FTIR, UV spectroscopy, SEM, and TGA. That's all from me. Thanks for watching.